All right, so let's do a few more problems for examples. So let's say we have, let's go ahead and number these as well. 2a to the fourth raised to the power 4. Okay, so this is the power rule. So we're going to raise each of these to the power. So 2 is to the first. 1 times 4 is 4. Then we have a. Now we have 4 raised to the power 4. So that's going to be 4 times 4. So that's 16. And again, sometimes they'll ask you to leave it as the base raised to a power. Sometimes they'll make you multiply it out. So just be careful and see what it is on each problem as you go through. All right, how about the next one? Say we have 2x times x to the fourth, y to the fourth, raised to the power 4. Okay. Well, first we have to get rid of the parentheses in the power, and then after that we can multiply by the 2x. So we'll leave the 2x out front. Now x to the fourth raised to the power of 4 is going to be x to the 16th. And then y is going to be 4 times 4, it's also 16. Now we have two bases that are saying we need to get rid of that because there's two of them, we need one. So it's going to be 2x. Now we have 1 plus 16 is 17, and then y to the 16. Okay, so this one, remember, we have to add when you multiply two bases. Let's say we do a fraction one. So we have 2m n to the fourth, 2m to the fourth, n to the fourth. So we're multiplying those two together, divided by m n to the fourth. And let's say we raise the whole thing to the power 3. All right. So I'm going to work across the numerator first, and then after that we'll simplify with numerator and denominator, and then after that we can raise everything to the power 3. So we have here 2 times 2, so that's going to give us 2 squared. Then we have m, and we also have an n. We'll raise those powers here in a little bit. Oops. That's to the third. So here we have m to the first, m to the fourth. So multiplying those is going to be 1 plus 4. So that's going to be 5. Here we have n and n, so it's going to be 4 plus 2. So that's going to be 6. All right, so now, again, we can do this and we could do the subtraction. So that would give us 2 squared m to the 5 minus 1, n to the 6 minus 4. And that's all, again, raised to the power 3. And so that's 2 squared m to the fourth, n squared cubed. Now we have to cube everything, so it's going to be 2 to the 2 times 3, which is 6. Then m, 4 times 3, which is 12. N, 2 times 3, 6 again, and so that would be our answer. Now back here, we could have also done 2 squared m to the fifth, n to the sixth, over m n to the fourth, all raised to the power 3. And here we could say, well, one of these cancels one of those, we have 4. 4 of those cancels 4 of those, we have 2. So we have 2 squared m to the fourth, n squared. And when we do that, we're all the way up to there. So that kind of leaves out that step. So if you like to do it this way, instead of taking and subtracting, that's fine as well. And when you do it this way, you always end up with positive numbers because you just want to get rid of one side. So if there was more of them in the denominator than the numerator, you'd say, well, 4 of those cancel, 4 of these, and you have maybe, 1 left over, or however it is. So when you do it the cancellation way like this, you're going to end up usually with positive numbers if you do it correctly. All right, so let's do another one. How about we have 2x squared y squared z to the sixth times 2x squared y squared z, and then that's all over. And let's say we have x squared z cubed squared. All right, so let's work in the numerator, and then we'll work in the denominator, and then after that we can simplify both of them. So here we have a 2 times 2, so it's going to be 2 squared. Then we have x, and we have x squared and x squared, so it's going to be 2 plus 2, which is 4. Then we have y, and it's going to be a 2 times, and this one's a 2, so 2 plus 2 is 4. Then we have a z, we have a 6 and a 1, so that's 7 over. Now here we have a x squared squared, so that's going to give us x to the 4th. Here we have a z cubed squared, so it's 2 times 3, which is 6. Now we can simplify. We can say, okay, well, I'm going to go ahead and do the cancellation method, and it's a little quicker usually. So 4 of those cancel 4 of those. 4 of those cancel 4 of those. We're left with 2. Oops, wrong thing there. Ha. All right, so canceling the wrong things out. All right, so now we can write the right thing here. So we have y's, we don't have anything different, but we have 6 of these. Let's cancel 6 of those. We're left with 1. So now what we have is 2 squared y to the 4th, and then we have times z. Now all the x's and z's in the denominator are gone, so that's all we have left. And you know, this one, maybe this is one where they say we'll simplify even further, so that would be 4y to the 4th z. And again, I don't know when they're going to tell you when to simplify and when not to simplify, so just pay attention to see what they say on those. All right, so let's do number 5. How about 2x squared y squared to the 4th times x to the negative 4. All right, so I'm just going to work from left to right. Anything in here we can't do simplification, so all we have to do is raise everything to the power of 4. So that's going to be 2 to the 4th. X, well, here we have 2 times 4, which is 8. Y, we also have 2 times 4, which is 8. And then this x to the 4th, it's negative, so we want to take it to the denominator and then becomes positive. And now what we have is we have 2 bases that are the same, so we need to get rid of some. So what I'm going to do is say 4 of those, cancel 4 of those, we're left with 4. And so what we have is 2 to the 4th, x to the 4th, y to the 8th. Okay, so that would be our simplified form with exponents only. All right, so let's try another one. Let's say we have u squared b to the negative 1 over 2 u to the 0 v to the 4 and times 2uv. All right. So first things I'm going to do is I'm going to take that negative 1 and take it to the denominator, and then I'm going to simplify the denominator as we go. So what we have is we have a u squared over, now I take that v down and it's to the 1 power, and then I have 2u 0 v to the 4 times 2uv. Okay, well remember, anything to the 0 is just 1, so that's 1. Now I've got 1v here, 4 v's here, so that's 5, plus 1 more v, so that's 6. So the denominator is v to the 6th. And then I have times 2 times 2, which is going to be 2 squared. Then I have 1u, so that's a u. And that looks like everything I can do. So what do we do? Well, one of these u's cancels one of these u's. We have 1 left. And so that gives us u over, and maybe if this one would say they want to simplify 4v to the 6th. Okay. And so that would be our answer to this one here. So we, again, we had all of those things put in, and we've now simplified it. All right, let me see. Where's the next one? How about y to the 3rd x to the negative 3 y squared over the quantity x to the 4th y squared to the 3rd. All right. So what do we have here? Well, what we have is a negative exponent up here. We've got 2 y's, so we can go ahead and already simplify a little bit and not in the numerator. And the denominator, we have to go ahead and take everything to the power. So if we have y to the 3rd times y squared, that's going to be 3 plus 2, so it's going to be y to the 5th. Now, if I take x cubed down and make it a positive instead of the negative, we have that. Now I need to take the powers here. So then that's times x to the 4 times 3, which is 12. Then y times 2 times 3 is 6. And so that's simplified. Well, these two, I can add the powers. And here, 5 of those, cancel 5 of those, we have 1 left. So it looks like we have 1 in the numerator. In the denominator, we have x to the 12 plus 3 is 15. And just times y. So that one's pretty simple. Comes down to just the 1x to the 15 and the y to the first from this whole mess of x's and y's all together. All right, so let's do one more for this section, and then we'll be done with this video. So let's say we have 2y to the negative 5 over 3x squared. And let's say that whole thing is to the negative 2. All right, because I have this negative 5 here, I'm going to take care of it first before I go ahead and take care of this one. So if I do that, that's going to give me a 2. The negative 5 comes down to the bottom, becomes positive, so that's going to be 3x squared y to the 5th, all raised to the negative 2. Now I'm going to make that positive by flipping the whole fraction around. So that becomes 3x squared y to the 5th, all over 2. And that's squared now, it's positive. So now I can square everything inside of here. So that's going to give me 3 squared x. Now it's 2 times 2, which is 4. Y is 5 times 2 is 10 over 2 squared. Okay. And so this is one, then maybe they'll say, well, what is 3 squared? Oh, 3 squared is 9, x to the 4th, y to the 10th over 4. So maybe this is one where they actually want you to simplify it. Might not be, but in any case, that would be something you could do there. So that is a list of more examples for 7.1.